Hi guys, today we're going to talk about something called similar figures, which are different than congruent figures. So we'll go over what similar figures are and how you solve when you have similar shapes as well as triangles. Okay, so similar figures, they are shapes that are the same shape but not necessarily the same size. So if you think back to when we did transformations, do you remember which type of transformation changed shape? I'm sorry, did not change shape, but changed size. Holy hot dog, you guys are right. It would be a dilation. So a dilation is when the shape stays the same. So the shape's going to look the same, but the size will change. So similar figures technically are undergoing a dilation, which is pretty cool, in my opinion. Okay, so two polygons are similar if their vertices can be paired such that corresponding angles are congruent. So what this means are the angles that relate to each other. So like your two biggest angles and your two medium-sized angles and your two smaller angles, they have to be congruent. Okay, so all of your corresponding angles must be congruent if you have two similar figures. Also, corresponding sides are in proportion, or if you divide the two sides between the two shapes that relate to each other, they will have the same ratio, or when you divide your fraction down, they will reduce to the same fraction. Okay, when we did a dilation, this is called a scale factor. So it's still going to be called a scale factor when we have similar figures. And remember, mathematicians tend to be lazy. So if you don't want to write out the word similar, you can use this cool little tilde symbol, and that means similar. Okay, so we're going to get started on example 1, which we have two similar quadrilaterals of some sort. And it says using the similarity statement, which is this right here. When you have the little tilde, that means we're writing a similarity statement. State all the proportional sides and congruent angles. Find the scale factor. So we want to know if these two shapes, well, I guess it did tell us they are similar. So we're telling or what we're doing is we are going to write down all the sides that should be in proportion to each other and all the corresponding angles which should be congruent. All right, guys, let's get going. Okay, so just like when we did congruent figures, I'm going to number, so we have quadrilateral cats is similar to quadrilateral jump. Clever, right? Cats jump. Get it? Poor slapper. But anyway, so I'm going to number 1, 2, 3, 4 above cats because similarity statements, just like with congruency statements, are written in a very specific order. And basically, the letters in the same spots of each similarity statement should relate to each other. So the two letters that have like a 1 above it should be corresponding. Okay? So our proportional sides. What I'm going to do first, I'm going to write all four sides of my first rectangle. So I have side CA, I have side AT, I have side TS, and I have side CS. Okay, and similar shapes should have proportional sides. So I'm going to be dividing each of these sides by the side that it corresponds to in the other quadrilateral. And when I reduce down all of these fractions, you should end up with the same value. So let's see what happens. So C to the A. Well, C to the A is a 1 and a 2. So the side that is proportionate to should also have a 1 and a 2. Which two letters in my other similarity statement have a 1 and a 2? Holy hot dog. That would be JU. It has a 1 and a 2 above it. Okay, A and a T have a 2 and a 3 above it. So which letters have a 2 and a 3 above them? Correct. It would be UM. Okay, TS has a 3 and a 4 above it. So M and P also have a 3 and a 4 above it. So I am dividing all the sides that have the same numbers above it. And CS has a 1 and a 4 written above it, which means the side it corresponds to is the side with a 1 and 4 above it, which is JP. Look at that. Okay, so these are all your corresponding sides, which if it's similar, if you did have values for all these sides, when you reduce them down, you should get the same number. So since we know that they are similar, when I divide the side lengths, I should end up with the same number, which is our scale factor. Okay, so like CA is 9, JU is 3. Okay, which 9 over 3 equals 3. Okay, so each time when I do this, all of my fractions should reduce down to 3 because they should be proportionate and have the same scale factor. So let's see, A to the T is 15, and U to the M, is 5. And guess what, you guys? 15 over 5 is, it is also 3. So there you go. And TS is 12, and P is 4. And 12 over 4 is also 3. Look at that. And CS is 18, and JP is 6. And guess what, you guys? 18 over 6 also reduces down to 3. Okay, so since they are similar, all of our fractions should reduce down to the same number, which we call our scale factor. Cool beans, right? I know. Okay, and now what we're going to do, we're going to write all the angles that should be congruent. So similar shapes have proportional sides, but congruent angles. So be careful. Congruent figures have congruent sides and congruent angles. So similar figures are a little bit different. So just watch yourself. The demon cats are always watching, so watch yourself. Okay, so our congruent angles. So we're going to write the angles that are congruent to all 4 angles in my original quadrilateral. So angle C has a 1 above it. So which angle has a 1 above it over here? That would be angle J. So angle C is congruent to angle J. Okay, angle A, well, angle A has a 2 above it. So which letter also has a 2 above it? Correct, you guys. It would be angle U. So angle U is congruent to angle A. And again, don't forget with your congruent marks, you put the same amount of arcs over an angle that is congruent to another angle. So since these two are congruent, I put 2 arcs. Since these two are congruent, I put 1 arc. And we just kind of keep adding on arcs to the different congruent angles so you can kind of see in your picture which angles are congruent and which angles are not. Okay, so angle T has a 3 above it. So which angle do you guys think is congruent to angle T? Holy hot dog, you guys are on a roll today. It would be M, since M also has a 3 right above it. So angle M and angle T are congruent. And then lastly, angle S has a 4 above it, which means angle P also has a 4 above it, which means it's congruent to angle P. Holy hot dog, right? So guys, when we set up our similar figures, basically your sides should be proportionate and your angles should be congruent. If this does not happen, if you do not have proportional sides that all reduce down to the same number, and if you don't have congruent angles, that means your two shapes are not similar. So just keep that in mind. When we do example 2 and 3, that's kind of what we're determining, if these shapes are similar or not. So I don't know. Let's see what happens. I don't want to give it away. So go ahead and get started on example 2.